Hello, everybody. Thank you for coming to today's Geospatial Studio. As you already know, it's about transferring and using geospatial data and use it as for 3D modeling in Blender. So, as my friends here in design are also here, we are always wondering why 3D modeling, why geospatial modeling in 3D for geospatial scientists. And I would say it's very important. First of all, you need nowadays a very intuitive interaction with your 3D data, where you can modify your data the way you want. It's not anymore about the maps or 2D maps. So it's very important to have a more intuitive interaction. The second one is scientific publications. For instance, if you want to, so this is Elsevier's new kind of update. So you can see you can have 3D models updated into Elsevier. So if you want to have your, for instance, 3D models here, you can see in your papers and your publications, you can put your 3D models, which pretty much used in terms of medicine, but not very much in terms of landscape. So imagine that you can have your landscape on your scientific publication available for everyone to interact in 3D. So let's go to the Blender. So I assume everyone have the Blender open. Great. So I will quickly first go to the interface. And if everyone can open the Blender file, geospatial.blend, on the line blend. And if you have a black screen, please minimize it. So yeah, so you already have that open on your system. I want everyone to see the pink, famous Suzanne, the sample 3D model in the Blender. So I'll quickly go over the interface. The Blender interface seems very confusing, but at the same time, it's very, very flexible. And how it works is that you have different environments, and all these environments come with a header and a button to change. For instance, I go here, you can see that you can change it from 3D view and use all these environments, which is now this one is set to 3D view. The same with these ones here and these ones here. So they're all in the same nature, but they have different content. I'll quickly go over some of these editors, which you will need to work with later. But definitely, this is a very, very huge work. And pretty much extensive material is available on the Blender website and elsewhere. So I'll start from 3D view, which is basically the main interaction editor for 3D data. So here, how you can interact with it in 3D, and then you can use your scroll the same as other softwares to zoom in and out. And in the headers, you normally find whatever you need in terms of that environment. For instance, you can view it in different formats and directions, left, right, and then again to the perspective. You can also have a camera view, with which you can see here in the camera. You can, again, with the scroll, go back to it. So that's how you interact with your 3D information. But that's not all. You can also switch between the way that you want to actually see your object and interact and work with object. This is the object mode, which you normally will see. You can also switch to edit mode, when you have access to more of the, so you can access to more of the detailed information. For instance, you can interact with vertices. You can click here where you can interact with the edges, or here where you can interact with the faces. So that's how you can actually define and how you can actually modify a model. You can simply move all the faces, vertices, and then when you go back to the objects, the same, you can use the handlers to move it in different directions. So that's how the viewer interface works. But you can also see here, which is the outliner, where you can see all the lists and information about your data. Here in this world, most of things are somehow hidden, but some of the things are, as you can see, visible. The left icon shows that you can see it in the image, and the camera icon here at the end shows that you can see it in the render view. It's small, I don't know if you can see it or not. So here in the outliner, on the far left of your screen, on the far right top, you can see all the information about the 3D world that you have here, from the camera, from the sample trees that I put here, the lamps, which are the lights, and also the Suzanne. So the next editor that you would basically need to go through is the info one. Here it's the main panel at the top. But again, all of these can change to each other. It's very flexible. You can change any of them to any other, so you can customize your own environment the way you like it. So in the info, you can find different layouts. For instance, the animation, 3D full layout, compositing. So for different uses, for even game design, you can change this to see different layouts set out for you. For instance, you want first to have your materials and then your code environment and a scripting all in the same time, but some other means you may need to have your video editor there. So it's based on your need. You can select all of these. And also you can change your scenes, and you can have different scenes, which basically allows you to have replicates of the same scene here and then work in different scenes. The last one here is about the render engine that Blender uses. So Blender uses different render engines. There are 3 of them here. You can see the Blender renderer, which is the most simple one. And I can switch to this, and you can see it changes because it uses a different shading and different lighting. I will leave this for you to learn more about it because it's very important. But for now, the cycle render is the one that we use. Cycles is more about ray tracing. It's in different cycles, gets different lighting systems and radiosity, so we can have a kind of real-time rendering and a very nice viewport shading. Oh, can I help you?
I think I got it.
I'm really sorry that I need to grow this to kind of go through this very fast because I think we need to go to the geospatial data. So the other environment that you need to know about is the console. The console is basically a Python console. You can type everything. You can have all the Python modules imported here. In the same time, there is a Python module called BPY, which is Blender Python, and the BGE, which is the Blender gaming environment. So through these 2 modules, you can actually do all the commands and everything that we will go through, and you'll see here through the command, which basically one console command. In the same time, if you change the console, for instance, to text editor, you can have your Python file open here, and then you can run your script. You can see the run icon far in the bottom. So this is how you can run a simple, for instance, Python script, which can have different means. For instance, you can have a procedural modeling completely set up in it that you can build the word from a click. And at the same time, if you want to know whatever you do, how it's translated into code, with Blender, if you turn on the info, so which is another environment, which I will now turn on, so you can see a list of the log of the activity you do. So for instance, if I move Suzanne, here it's reflected. So this is exactly the code you need to move Suzanne for yourself. You can put it in Python. You can put it in Python, copy paste it in Python console, and see the same happening. It has the coordinates and it has the command. And you see it uses BPY operation system transform. So this is the kind of a module that uses and the function that moves Suzanne. And the last one, but not the least, is the node editor. The node editor is where you can actually modify your materials in the world. In this class, I'm not going over the materials and textures, but it's enough for you to see some setup for materials that I put here. For instance, simply each node defines how you want to actually manage and order the textures and different qualities of your surface to the attributes of the surface to the material. For instance, you can see the mix shader, which mixes two materials, the glossy and the diffuse, together and attributes it to the surface of the Suzanne. So here you can basically define, and you can have a very complex material defined for a real-world object that you can achieve the reality. So going back to the 3D view, there's something which I forgot to say about, is how you can differently see your environments. So the one that on default is the material, which shows the object with the material. You can have it to the texture, which shows the texture on it, or you can have it as a solid material, or a wireframe. You can also have it as a bounding box, which is very important when you have a complicated scene. So you have thousands of trees, but you don't want to render it all in the same time in your viewport. So you just select it to the bounding box, and that's all. You can also have it far on the top, the render, which is a great feature in Blender. So you can see as you can move it, it's in real time, it renders everything. So I will put it back to the material. So the focus of this studio is more about how you can transfer and use geospatial data. Normally in 3D environments for designers, it's very, very, very difficult. Why it's difficult without georeferencing? Because, for instance, you have a city. You want to have all the objects in your 3D model, all the buildings and all the environments or all the components of a landscape. If you don't have proper georeferencing, you need to import them in 3D environment and just move all of them and align them in the place they should be. With georeferencing, you can set up your georeferencing and import everything as a pipeline into your 3D model. So you can have everything on the same place. You can import a huge chunk of geospatial information, extrude them, and have it as a 3D model. So that's a benefit that you can use that you can benefit from the GIS add-on, which you installed earlier. So how the GIS add-on works? Basically, all the add-ons that you install in Blender is accessible in the user preferences, which normally comes in a So normally the first time that you open it, it might not open, and then you close it, and then you select again, and then you have the user preferences. So if you go, yep, a bit. So if you click on the Blender icon on the Windows, here, yep, there. So that's the second window. Try to activate it and then close it again, and then you will have the preferences. Does everyone have the preferences open? Okay. So from the preferences, you'll here need to search. There's a tab button here, search, where you simply search for Blender GIS or just GIS. So you can see the Blender GIS add-on here. It's normally deactivated, you activate it. And please expand it. So this is the most important part. Normally how the georeferencing works is that you need to have georeferencing set up before in the spatial reference system. You need to have georeferencing for each of the objects that you import. So if you know what's your georeferencing of the system, and if you know what's the georeferencing inside the preferences and the georeferencing of the data that you import, you're good to go. So here I want to add our examples coordination reference system, which we call it CRS. I added here. Most of the CRS are available here. You can search it, for instance, for the famous one, or typical ones. Let's say not. And it takes a bit of time, and you can see like a list of coordinate system available, but unfortunately the one that we use for this example is not available. So I close the search button. Here I use a definition. So what is the definition? It's SSRID, that we all know. It's a unique identification number for your georeferencing system. I'm going to use 3358, which is for North Carolina and not 83. And here I changed the description to not 83, North Carolina. And I here make sure to save it to add-on preferences, which means that you have it from now on. So that's enough for the preferences. You can save user preferences here, that every time that you open your Blender, this is pretty much saved. So you don't need to define it anymore. Now, as soon as you activate the Blender GIS in your 3D view, here in the Tools button, you can see the GIS. This is how you can see. So for you, I think it's already set up. So here you need to add 3358. Okay, I didn't put a definition. Okay. So here you should see your scene georeferencing. It's now set to what I defined, but it might not be the case, nor always. So you should make sure that this one, the scene georeferencing, is set to your preferred georeferencing in CRS. If not, you can easily delete it here, and then again set it and use it from the ones that you added previously to the preference system. Okay, so once you have this set up, it means that you're good to import your geospatial information. I now navigate to import, and as soon as you install the add-on, you will see that the options of georeferenced raster and shapefile and OpenStreetMap are open for you. I'm not going to go over the OpenStreetMap, but good to know that you can have online information and your web system set up here that you can have, and you can download all the OpenStreetMap layers inside the Blender. So you can see how it is easy to import the whole city into your Blender file. So we'll start from georeferenced raster, which basically would be our terrain. So let me delete Suzanne. You can right-click on it and then push delete. Simply, it will go away. And click georeferenced raster from import. So please navigate to your downloaded sample folder, which is, in my case, it's on my desktop. And go to the project folder, please. So you can see the orthophoto and DEM. So what we'll do is simply, it's a DEM. It's a digital elevation model written in 32 bytes format. 32 bytes format, as I tried, is the best configuration you can have when you want to export your data. So make sure that from any GIS platform that you're using, from GRASS to QGIS, export it as a 32 bytes information data. And then make sure that the georeferencing is set. Also make sure that you don't have a very coarse resolution, because if the resolution is very coarse and low, it will import it as a flat surface. So if you see the flat surface, these might be the issues. Here on the GeoRaster, you can see that you can have it as a DEM, which basically, it means that you can convert the whole geotiff from 2D to 3D here. It reads all the elevation information to make a 3D model of the terrain for you. I think that's the most significant feature, because normally if you want to use point clouds or you want to use other means to make 3D models, it takes a lot in the 3D interface actually to triangulate and have a surface. So this is a ready surface for you. You can here define it as a mesh or a subsurface. It's enough, I think, at this point to know that mesh is a kind of a 3D format that is best readable and editable in Blender. So how many ways you can download the raster? You can have it as a DEM. You can have it as a raw DEM, which means that you can have it as point cloud. And then you triangulate yourself. You can have it on mesh, which means that you can have, for instance, if you want to drape the whole order photo on a point cloud, you can drape it on your mesh as georaster. You can also have it as a background or simply on a plane. So these are the options you can have. And this session will go only to use it as a DEM. And then here, you should again define your CRS. So again, in 3 places you need to define. First, in the preferences. Second, in your scene coordinate system, and here in the import. If those three are kind of compatible, then you will have your terrain imported instantly on your 3D model and accessible in your 3D view. So now I will go over the shapefiles. Shapefiles are a bit different. I go to import and then shapefiles. So again, in your project folder, there is an SHP folder which has buildings on it, and it has a point cloud files. So I put buildings as a sample file here, and in the building shape, there are some attributes that are defined in GIS. Those attributes include the height of the building, and also the elevation of the building from the surface, and also the name of the building. So we want to see how they can be translated into 3D objects. So here, in the first import kind of procedure, you don't need to define the coordinate system. So you double-click on the buildings, and there would be a dialog opening for you. This dialog actually asks you how you want this shapefile to be imported. So you can say elevation from the field, select it, and then use the elevation attribute, the elevation field. This is exactly the field that you have in your GIS file. So I will use elevation, which means that I define that the buildings each would be on the separate elevations on the terrain, and then extrusion from the field, which means that I want those 2D shapes to be extruded in a separate defined elevation height. So I put the height here, and then it asked me, do you want to extrude it along Z? And I said, of course. And here is the separate objects. So if you have a big shapefile, you don't want it all in different particles and objects. Sometimes you want it just as one mesh, so you can easily interact with it and work with it. So in that case, you won't put separate objects. It makes the computation very, very difficult. Put the object, click on the object name, and you'll see that here is the building denotes the object name. So it's basically the building name. And you have again the CRS. This is now set to not 83, the ones that we defined, but sometimes it's not. So please make sure that it's the same georeferencing you want. Which in this case, I think it's not. You have the same problem?
Also, in the instructions on your repository, you have ESPG instead of EPX.
Okay.
So there's a typo. So if someone's just copying and pasting that.
Oh, okay.
And I think there's a space that maybe there shouldn't.
The number is enough. So the number is just enough. sure. So I think because I use GIS and I use grass separately, there should be some misallocations between the feet and the meters. So as you can see, definitely the scale also doesn't match. So that's probably the reason. One of them uses feet, one of them uses meters.
It could be U.S. survey feet versus international feet.
That wouldn't do such a thing.
That's more likely. What part of the state is that in? Raleigh?
Sorry?
Is that in Raleigh?
Yep.
Yeah. That difference could be if one was entered in international feet and the other was entered in U.S. survey feet.
It might be the case.
Source of the
Yeah.
discrepancy.
But fortunately, I have this thing ready in my file as a backup. Let's move to the solid so we can see it. So let's now import the point cloud. So why I use point clouds? Because you normally need point clouds for different means. I extracted point cloud LiDARs class 5. Point cloud LiDAR class 5 is normally for high vegetation. And I put it here because I want to just know that in my field and my terrain, where are the trees exactly and what are the height of the trees. So hopefully, so this is LiDAR high vegetation file. That again, double click, I make sure that it's North Carolina. The 3D objects that you take from GIS, you don't need to do anything with them. You just say OK. So here you can see that the buildings that we downloaded, they all have a different name. They have residence, Oxford building, they're all simple names. Sun Health Center, for instance. So this is how you can actually import it from GIS in unique names. And this is the point cloud. So you can see that from here, if I select it, I can see how the height of the vegetation is visible here. So we will use this now to actually populate trees on the landscape. So first, just to have an idea of how this landscape looks like, let's define an orthophoto picture and drape it on this one. So I prepared a material in this scene, which is called terrain ortho, which is now assigned to it. But you can also assign different materials to objects here in the material. And then make sure that the material is on. So you can see different colors, different materials are defined, and you can just assign it to the object. So let's go to the orthophoto, which I've done before. But intentionally, I didn't put the orthophoto in it. So we can go together through it. So here is in the node editor, this is one of the nodes, the image texture, which you assign it to the color of a diffuse shader and then to the surface of the material. So here is just enough that you navigate to the browse button, go to the SAMP project folder.
Can you move to some object? Because I'm lost in the scene. I don't see anything. Can you zoom to data or make sure it's visible? Or
yeah. Play with numpads. So 1, 2, and 3 are basically the ones that select different interactions with your objects. And then here from view, you can have different interactions also with the objects. But if you have the scene, it's enough for you just to put numpad 0, which goes to the camera that I defined before. Then go to View, Camera, numpad 0.
Oh, okay.
Okay,
Thank you.
sure. So here I navigate to the order photo. I go to the folder, to the project folder, and I open it as an order photo. So you can see the order photo is defined as a texture of the material of this object, which is now draped onto the terrain. So because of our bad georeferencing, the buildings are not in the place. And this is exactly the same problem I told you that you normally face if you don't have good georeferencing.
But when I open it in QGIS, it looks fine. The shapefile.
The shapefile is fine. I think the sample I provided in the provided as a raster in the repository is by mistake a different file. It's a completely different geometry.
But in QGIS, it matches.
It matches? Okay. So here we have the trees, and then we have the texture, and then we can see how the trees may look like. So the next step would be to populate trees. How you can populate trees? You can simply download and you can design your own 3D trees into the Blender, and you can copy paste. But we want to make it more intuitive, and you want to make it simpler. So what we do, so here I have two objects. One is the CGIS tree that's here as a sample tree, and I have an evergreen tree. We just imagine that these trees are the trees that are actually in the landscape. So what we want to do, we want to define it, we want to actually scatter all these trees onto these places, and we call this a particle system modifier. The particle system actually uses some particles, which we call it hairs or emitters, on the surface of our object. That's how it works. And the way that you can actually have control over it, we call it vertex groups. So if you remember again, we have the edit mode, where you can see all the vertices of your plane. So it's basically you define through vertex groups that where you want these trees to be populated. And how you do it, let me go back to the object mode. Here you have, in your properties tab, so when you select your terrain, it's the force from the right. And here you can see I predefined two vertex groups. I can define another one and multiples. So it defines which vertices you want to group together. And how you group them together, there are different ways. You can select them, but you can also go again to the object mode, and here you have a weight paint. So let me go to the evergreen. First we want to plant the evergreens. So I go to the weight paint. So this is actually simply you can paint on the landscape where you want the trees to be populated. And why it is called weight? Because you can assign different weights. So if you here on the far right, on the far left, if you have, for instance, 50%, you can here have it as 50%. This basically means that the priority that you set and the weight of these two are different. So if you want to have in total 200 number of trees, the most will go here, basically. Or sometimes you have higher density in the middle, for instance, and then you have lower density on the outer of your patch. So let's just paint over this. I'll go to the object mode to see where am I, have an idea where am I. So I want to make sure that this area is completely populated with trees. I go again to the weight paint, assign it as 1. Paint here. We'll come back to this, but let's see how it works. So here, so on this tab, next to the vertex group, you have something which is a kind of a tool shape. This tool shape is your modifiers. You can set a number of modifiers to your objects, but the one that we're going to use for this one is the particle system. You can see with the particle system, you can scatter things around in your object, but we had a particle system assigned to this before, just to make it easy. You can expand the particle system tab with, let's go back to this again. So you can push this one to expand it, and then you can here find your predefined settings. So I've defined as a predefined setting the evergreens. So you can see now the evergreens is all over the landscape. So what it basically does, here you define what kind of trees you want and what kind of object to be scattered on surface of this one. I simply said scatter evergreen on it, the evergreen tree. I can simply say scatter the deciduous one here, or I can say scatter the Oxford building on it. It really doesn't matter. So you can scatter everything. So let's go back to the evergreen. So, and there are a considerable number of parameters here. So that's, I think that it needs further review and further read to the tutorial of Blender to get completely dominant on this. But for now, you can see the number, which basically you can change the emission number, and the hair length, which is simply the height of your object. You can also randomize it. So this is the randomization. You can randomize it completely, or you can randomize it none. So how you define your vertex group here? So remember that we had our vertices group painted here. So in one of the tabs there are vertex groups. You just simply open it and say evergreen. So you can see how the trees are populated. Now we have set 1,090 trees. We can have more. So I can see that there's a small patch also here that I want the evergreens to be on it. So that's how it goes. And the number is now a bit crazy, so let's make it 500 total. And here with the weight, you can see how it works. The one that has complete weight 1, it's completely dense, and this one is a bit fragmented. So let's go to other type of trees. I define another particle system for this. Second one, I go to the setting. This time I select the deciduous ones, which is again a preset. And then go to my vertex group, and this time I select deciduous trees. Now I want to paint deciduous trees. So I can see them basically on where I want to go back to see where they are. And then so you can imagine you can be much more precise with this. I go back to the particle systems and select the density group, this time as deciduous. So you see I have two types of trees. Sometimes you want to mix, so you can have those in between of here, have those between here, just to make it more fun. So now you have all this. Put it to material and then to the object mode to see how it looks like. And you can hide the vegetation from here and make sure that it is hidden from the render as well. So that's how your landscape looks like. You can add other levels. Imagine you can add roads, you can add other surfaces on it, just to make it more complicated. But the other thing that you can use from here is basically, so how many of you know Sketchfab? Sketchfab is an online 3D modeling and I would say 3D visualization website where you can have complete interaction with your 3D form. And this is pretty much well integrated into Blender. So inside Blender you can go to your user interfaces and here just type into preferences Sketchfab. So this is Sketchfab exporter. And then from Sketchfab, you simply make a username and you upload your model from your Blender into the Sketchfab, which means that you can contribute and you can share your 3D form and your 3D data with everyone. Simply just go inside it and then first try to download your terrain, work on it a bit, and then upload it on Sketchfab. You can simply easily interact with it and define materials, define motion blur and all those effects here to make a nice landscape. So about the video editor that we came before. So it's, as I said, Blender is not only about modeling. You can have everything together. So just as a sample project, we had someone design a landscape, specifically Wojciech here, design a landscape on tangible landscape. So as you can see, all the geospatial data is pretty much kind of streamed in, from grass into Blender. So we coded everything, so everything is automatically inside. So as he designed the landscape, the model get updated. So you can, for instance, with the video editor, one sample aspect is that we had all the video here edited like completely like a professional video editing, like Adobe Premiere, and have different activities that he had with this set up. And we had the 3D model, we had the output, we had the video. So everything together in one interface. And I think that's very valuable. So you can couple things, you can couple different interfaces and works together in one. So you can, for instance, in this one, process how the designer worked through, how the model get updated, and at the same time how his behavior changed. So let's go back to our model and just simply say, talk about rendering very quickly. So the output is not the 3D model that you take out. You can have it as a very, very sophisticated rendering. So for the Blender rendering, it's normally hooked to your camera. So if you remember on our outliner, we had a camera, which I think I deleted, and that's good. So here you can add camera on your ad. So there's simply a camera here, and then when you have the numpad 0, it goes to the camera, which is basically now nowhere. But the way you can do it, you can set up your desired view and just say Alt-Control 0, which sets it to that view. So I changed some of the camera parameters just to define the clipping. And again 0. So this is the view that I defined for the camera. It can be even farther. So I want it from this distance. Again, I set Alt-Control 0, which sets my camera to the desired view. So basically, you don't need to move all the camera in the places you want. You just can look it in your perspective view and set the camera to it. And you can access the render from two places. One here from the info panel on the top when you say render image. You can also have access to all the rendering parameters here from the Properties tab. When you can set the dimension of your render output, for instance, yep. And then your output parameters like the file, and then just click render. Oh. Now we can. So all the things that I hid from the rendering, made invisible from the rendering, you need to turn on. So this is a very low quality rendering, but you can set it to any parameters you want. So this normally for rendering takes time. It's not instant, but at the end you can have a very high quality rendering of your environment, with the trees on it, with the buildings. It's up to you how you want to actually set the degree of abstraction of your scene. You can have it as completely textured buildings. You can have it as abstract buildings. It's really up to you how you want to represent your environment. But the possibilities are infinite in Blender, I would say. Well, while it's rendering, I can take questions. Thank you very much. And accept my apologies for the raster file. I will make sure that in the GitHub, I will upload the good one.